Okie dokie. So, I've been thinking more about light. I'm gonna start here. So, first, I wanted to show my idea what I discussed in the previous videos of light, how it moves at the speed of light. And because it moves at the speed of light, space condenses around it. It experiences space condensing. Yet at the same time, space is expanding all around it. This is what I wanted to figure out, demonstrate, illustrate, whatever, what have you. I wanted to show this. I know it's not the best, maybe the example, but it's just what I'm trying to get out of my head. So, space condenses around the object, which is a photon or light, ish, and then it also is expanding everywhere. So I started here. I wanted to demonstrate or illustrate the general idea of space and light inside of space, because that's typically how we think of it. Photon, the wave, the electromagnetic wave, and then space. And I showed these arrows to show that space is expanding everywhere. Expanding up, down, right, left, and in depth this way. So this square this way, and then this square this way. And because space is condensing as it travels through space, I went ahead and illustrated that. So I went from here to here, space is condensing, and then here to here, space is condensing more. You could see the arrows, how they're still pointing up, down, right, left, and depth, both ways. Which leads me here. So you could see I collapsed the dimension of length, or no, that's width actually. The dimension of width, we'll call this width. So I collapsed the dimension of width until it was a square. Don't be fooled by the diagonal arrows. Intuitively you want to think that the arrows should go here is because these sides are expanding, but it's actually this depth, this square, this depth line right here that is expanding. That's what this line is. It's expanding outward, down, up. Because light is traveling at the speed of light, space condenses around it. One interpretation is you could say it condenses all around it, so then it would literally just be a point nowhere. But I'm just gonna continue anyways. So it's a photon in 2D space because it's traveling at the speed of light through 3D space. So I moved on and I asked, what if space kept expanding? So I used this and I drew it again, showing that it was bigger, that space expanded. And I realized there's no room for the wave. It's just the photon. It's just the existence of the light. from start to finish as physics predicts, where it doesn't travel, it only arrives. So it's there and then it's there. And I realized there's no room for the wave to even exist. Space keeps expanding as we theorize it to do. But the way that light moves through space, there's no room for the wave to exist. You wouldn't put the wave to the side because it's traveling this way. It's traveling in the way that we condense the dimension, which is what it should be doing, I believe. So there's no room, there's no dimension for the wave to exist alongside the photon. What I did here was I continued, or I reconstructed the 3D space to allow room for the wave to exist. And then I put a person here just to kind of help ground it. So we have light. And then we have the electromagnetic wave that propagates through space-time. What I did here was I took this example